Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the June 2023 International A-Level Statistics essay. The volume of juice J milliliters extracted from 1 kilogram of apples is modeled by a normal distribution with a mean mu and a standard deviation sigma. Given that mu equals 500 and sigma equals 25, use standardization 3446. Okay, so we got to find the probability that the juice is greater than 510 milliliters and show that that ends up being 0.3446, hopefully. So what we're going to do first is I'm just going to, write down the kind of format, the notation of, this normal distribution. So the juice is such that it is normally distributed with a mean of 500 and a variance of 25 squared. Okay, you write the variance here. All right, so that's this information written down in this form. See something written like this, it means exactly that. It's just written in the format instead of having it in words. Okay, now we have to show that the probability that the juice is greater than 510 milliliters. I'm going to get the normal distribution curve, which I have one prepared here, instead of having to draw it messily. Okay, so we have the normal distribution curve, and we're going to just use this to think about how to deal with this question. So basically, they've given us some actual values, some volumes, okay, which is the J values, okay. What we're going to do is we're going to consider the Z values, which are the standardized values. So the J value of the median is 500. And the Z value of the median or the mean, okay, sorry, it's mean, median, mode, but mean is 0. Okay, so we're going to standardize these values such that we end up with a normal distribution with a mean of 0 and a standard deviation of 1. Okay, now 510 is over here somewhere. Okay, it's above the mean. And the Z value we find will tell you how many standard deviations this is above the mean. Okay, how many standard deviations it is above the mean. That's what the Z value tells you. That's what the standardized value is. It's how many standard deviations above or below the mean something is. If it's above the mean, it will be a positive value of Z. If it's below the mean, it will be a negative value of Z. All right, so now, how do we standardize the scores? We take Z, and we say it's equal to X minus the mean over the standard deviation. This will tell you how many standard deviations something is above or below the mean. So we want to find the probability that the juice has a volume of greater than 510. So when we standardize this, it's going to be the probability, it's going to be equivalent to the probability that Z is greater than. Now we standardize the score by putting it into this equation. So you have 510 minus the mean, 500, okay, and divided by the standard deviation, which is 25. Okay, 25. So that's going to be 10 over 25. So you say it's like the probability that Z is greater than, the probability that Z is greater than 10 over 25, which I think is 0.4. 10 divided by 25, which gives you 2/5, which is 0.4. Okay, so we want to find this probability. Okay, that's what we want to find. Now, we're gonna so we're looking for this standardized score. The standardized score is 0.4. This is what the Z value is of this 510, the standardized score for it. Now, when we go to the table of values, okay, first of all, we won't find the value of 0.4 in the Z tables in the small table on the top. If we look at the Z values, we don't find 0.4. So we can't use this table, right? So we have to use the second table. And we have to look for 0.4 in this table. We can find 0.4 over here, okay? So we do have 0.4 over here, which we're going to then take. All right, that's going to be the value that we need, 0.4. However, we have to think about what that number associated with 0.4 is in the table. So 0.4 was somewhere over here, for example. Okay, now I'll just post this here so we can see. All right, so the 0.4, we have 0.6554. What that means is the area to the left of this value, because, all right, this is, the area between negative infinity until the z value that we have. So it's the area to the left of 0.4 is 0.6554. Okay, that's this area. This is 0.6554, all right? So that's what we found when we have used this value, okay? Now, is that what we actually need? Well, no. We're going to just go to the other page and explain that in more detail. So let's just get rid of this. Okay, and go to this page. Let's just paste this and make it smaller. Okay, so basically the 0.4 is over here. And what we found here is the area to the left of it. Okay, so what we need is the area, what we need is this area here. That's what we actually need. What have we found? We've found the area to the left of it. The 0.4, okay, the area associated with 0.4 here is the area to the left of it. So what we can see is, what we should understand is the area of the whole thing is 1. The area of the whole thing is 1. So what we want is like 1 minus the probability that z is less than 0.4. And this is the probability that z is less than 0.4. That's what this represents. And we want to find this other area, which is 1 minus that. So our answer will be 1 minus 0.6554, which should give us exactly that. So we're going to do 1 minus 0.6554, which gives us 0.3446. Okay, exactly what we wanted to find or show. Okay, and there's the answer to the question. Okay, so this is the same as saying the probability that the juice is greater than 510 is equal to that. Okay, so there we have the answer to question A part 1. Now for A part 2, it says calculate the value of D such that the probability that J is greater than D is equal to 0.9192. Okay, so let's take this and put it down here. Okay, so we want to find the value of D such that the probability that J is greater than D. So we're going to have our J values, we're going to have our Z values. Okay, we want to find the value, we want to find what D is such that the probability that J is greater than D is 0.9192. So D has to be in such a place that to the right of it is going to be the majority of the area. Because if the probability that J is greater than D is 0.9192, that means the majority of this area has to be greater than that D value. Okay, so you've got to understand that it must be to the right of that D value. So if, for example, if I put the D value over here, okay, now the probability of J being greater than this D value, it's going to be this area over here, which is way less than half the area. It has to be more than half the area. It has to be almost a whole area. So more than 90% of the area has to be to the right of the D, the value that we need. So our value D is going to be over here. Okay, so this is going to be the value of D. Okay, and we want to find what the Z value for this is. And that's going to be the value such that 90% of the area is to the right of it. So such that the area over here is going to be 0.9192. Now, unfortunately, the Z values, we need to find the Z value first, which is associated with this. Okay, this Z value, we need to find what it is. And then we can then find what the Z value is. Once we found the Z value that's associated with this, we can then kind of undo the standardization. Remember that the Z value is equal to X minus mu over sigma. So if we know what this is, okay, the Z value, we know what these two are, we can find what the actual score, which is going to be our D, is going to be. So we need to find the Z value. Now what we should understand from this standard deviation here, or this normal distribution here, is that the table here only gives us values of Z which are positive. It only gives us values of Z from 0 onwards. Our value of Z is somewhere over here, and we can't find Z values for that. So you won't find an area of 0.9. The highest area, you won't find an area of to the left of something that's 0.9. So I can't find an area over here and find this small area, this part here. Okay, because the area starts from 0.5 and goes up to 0.9. Why? because it starts from here and it has areas to the left going all the way to the top. So we can't have a small area. I can't say, for example, let's find the area of this section here, 1 minus that, and find the probability of that from, or find what the value of z is for that area here, because we don't have a negative areas. But what we do have is we have symmetry. Okay, so what we can say is that there's another value of z, okay, which is going to be on the other side of the screen over here. 1 second, what's going on here? Let me just fix this. Okay, there's going to be another value of z. This thing doesn't want to move. Okay, I'll just draw it again. Okay, so there's going to be another value of z, which is going to be on this side. Okay. Right. Now, that value of z, which I'm going to call minus z, okay, is going to have the same value, or it's going to have the same area to the left of it as this has to the right of it. So the area to the left of this, which I'll just put in a different color. Okay, this area over here is going to be the same as the area to the right of this. So I can say from this that the probability of, you can say, z being less than, or being greater than what we're looking for, is going to be equal to, okay, the probability that z is less than what we call minus z. Okay, less than minus z here. All right, so this area, okay, this area is going to be 0.919192. Okay, so we can say the probability that z is less than minus z is equal to 0.9192. Okay, so we can find the value of z for this by looking for this area. Okay, and what we'll do is we need to find the value of z, and our answer is going to be not the z that we find, but the negative version of it. So if we go back to the table and we look for 0.9192, 0.9192, it's right over here. If you don't find it exactly, you find what's closest to it. But in this case, we found it exactly. Okay, so we take this section over here, we bring it back to our page, and we use that now. Okay, so hopefully you understand what I'm doing here. So basically, what I know is that this z value here, which is going to be 1.40. 1.40 is this z value over here. This is the value of z such that you have the area to the left of it of 0.9192. Okay, and there's another z value over here, okay, which is going to have the area to the right of it of 0.9192. Okay, it's going to be because of the symmetry. So we can say that this z value has to be equal to the opposite sign of this one, so it's negative 1.4. Okay, so we can say that the z has to equal negative 1.4. So once we found the z value, we can undo the standardization. We know that z equals x minus mu over the standard deviation. So we can say minus 1.4 equals what we're trying to find, which is d, okay, minus the mean, which was equal to 100, minus 1.4 times 25, and that will give you your answer, which is 465. So 465 is the value of D, okay, which is the volume of juice such that 90%, 91.92% of of the cartons or whatever have more than that volume in there. Okay, so that's the answer to part A, 1 and 2. Then it says Zen randomly selects 5 bags of each containing 1 kilogram of apples and records the volume of juice extracted from each bag of apples. Find the probability that each of the 5 bags of apple produce less than 510 milliliter of juice. So that means the first one and the second one and the third one and the fourth one and the fifth one, all of them have to have less than 510, all of them. Okay, so basically what we can do is we can take the probability of the juice being less than 510, which is basically, the opposite of this. It's going to be 0.6554. Okay, so opposite of this is going to be this area over here. Okay, that's going to be probability the juice is less than 510. So that's going to be 1 minus that value. Okay, so that's going to be 1 minus 0.3446. So we're going to take this and we're going to have to raise this to the power of 5 because five picks in a row, right? So the first, the second, the third, the fourth is going to be this one. The probability of this times that times that times that. So is that to the power of 5? And that will give you your probability that you want. So we have 1 minus 0.3446 raised to the power of 5. And that will give us our answer, which is 0.1209. 0.1209. It continues to 3SF. We should say 0.121. There's the answer to part B of this question. All right, so we've done part A, 1 and 2, and part B. Now for part C, it says, following adjustments to the machine, the volume of juice R milliliters extracted from 1 kilogram of apples is such that the mean is now 520 and the standard deviation is K. So we've got a different situation now. It says, given that the probability that the volume of juice R is less than R is 0.15, and the probability that the volume of juice is greater than 3R minus 800 is equal to 0.005, find the value of R and the value of K. So we got to use these two pieces of information to find two unknowns. Okay, let's start with the first bit of information. The probability that the volume of juice is less than R, which we have to find, is equal to 0.15. So if we take our normal distribution curve, okay, and put this over here. Now, we know that the probability that the juice volume is less than R is equal to 0.15. So we can see here that the R must be somewhere on this side, because the probability that the juice is, the volume is less than that is a small area. It's less than half the area. So here, less than means to the left of, and the area to the left of has to be something less than a half. So it's going to be somewhere over here. That's going to be the value of the R that we're looking for, right? And the area here is 0.15. So we need to find this Z value. We need to find what this Z value is from this information, okay? So what we can do is we can understand that there's going to be another Z value over here like we discussed earlier, which is going to be the opposite of this Z. So I'll put minus Z, for which the area to the right of this is 0.15. Now, why am I saying to the right of this? Because when you're able to find an area like this, 0.15, you must go to the table on top if the areas are these kind of values. If you can find the area in the table on top, which we can, okay, we can see in this table here, P stands for the probability or the area, and we have the area here, and this is the Z value for which this area is to the right of it. The top table here tells you the area to the right of a particular value. So it's going to tell us this area over there. Okay, so basically we have this area and that's a Z value associated with that area. Okay, so if we go back to our question, okay, then we can understand. In fact, I forgot to bring the Z value back with me. Let me bring it back with me first, in case I forget, I don't want to be memorizing that. So I'm going to take this with me. Okay, I'll post it here. Make it smaller. All right. So now what we can say here is that this Z value here is going to be 1.0364. That's a Z value here. But that's the opposite sign of what we need. We need the one on this side. It's going to have obviously a negative Z value. So our Z value is negative 1.0364. That's the value of Z such that 0.15 area is to the left of it. Okay, so we use this table to find what we need. Okay, so now I can basically unstandardize this score to the best of my ability. What do we know here? We know that R is such that it's normally distributed with a mean of 520 this time and a variance of k squared. So remember, Z equals X minus the mean over the standard deviation. So in this case, our Z is negative 1.0364 is equal to our X is our R, which we don't know, minus the mean, which is what we're told is 520, over the standard deviation K, which we don't know, we have to find. So from this, we get the equation minus 1.0364 is times K is equal to R minus 520. So this is like one equation that we found, but we need some more information. Why? Because we have two unknowns. So this is where this second part comes in. Okay, this is where the second part comes in. So I'll just take this and bring it down so that I don't have to keep scrolling up and down. So we have this information as well now, okay, that we have to deal with. Okay, so let's deal with this now with this information and try to get another equation. And once we've got the other equation, we can then solve them simultaneously, it seems. So let's just take this and deal with this also. Okay, so remember we have R is such that it is normally distributed with a mean of 520 and a variance of k squared. That's the information we have about R. So now it says the probability that R is greater than 3R minus 800. Okay, I'm going to call this X now. So let X be, just to make it a bit less to write down, 3R minus 800 is X. Okay, is equal to 0.00005. Okay, so it's greater than. So we're looking for something on this side, on the left side here, on the right side here, sorry, such that the area to the right of it is really small. It's a very small area. Okay, 0.005. So it's our Z value is somewhere over here, and we got to find what X 3R minus 800. So we can find what X is, and then we can deal with that in a minute. Okay, so now, what is that value of Z such that the area to the right of it is 0.005? Let's go back to the table of values and find. So 0.005, do we have that here? 0.005, yes we do. Okay, so we're now looking at this. Okay, 0.005. Okay, that area is going to be associated with a Z value. So we have a Z value here, and this area to the right of it will be this much. So we've worked out the value of Z, and then we can work on our unstandardizing and then our simultaneous equation. So let's just post this here so we've got everything clear. Okay, so here we have the value of Z. The value of Z here, this is equal to, oops. Let me get the proper pen back. This is equal to 2.5758. That's the value of Z here. So as we know, X equals, Z equals X minus mu over the standard deviation. In our case, it's 2.5758 equals our value, which we're going to call it capital X, minus mu, which is 520 over K. So we can say that 2.5758 2.5758K equals X minus 520. Now our X here is equal to 3R minus 800. So now I can just write that in here I just wanted to make it less confusing until now. So I can just replace this X now with 3R minus 800, and that's minus 520. So you have, let's see, 800 plus 520, that gives you 1,320. So you'll have 2.5758K equals 3R minus 1,320 And that's our second equation. So we have these two equations. We have one equation which is minus 1.0364 K equals R minus 520. That's equation number 1. And we have 2.5758 K equals 3R minus 1,320. And that's equation 2. Now, to solve these simultaneously, what I'll do is I'll multiply the second equation by 3 to make the first equation by 3 to make the r's the same coefficient. Okay, so I'm going to take these numbers and multiply them by 3 and write them underneath. So I have this one, I have minus 1.0364 multiplied by 3. That gives me minus 3.1092 minus 3.1092 K. Let's make sure we don't want to make it write down the wrong number here. Okay, equals, this will become 3R minus, and we have 520 multiplied by 3, which gives you 1,560 minus 1,560, and that becomes equation 3. So now I can subtract these two equations. I'll do equation 2 minus equation 3. And when I subtract these, they have to be added together. So that was this answer. So let's just do it. 2.5758 minus, which could be plus 3.1092. That gives me 5.685. So 5.685 equals, K, because there's K's there. All right, that's the number of K's, equals 3R minus 3R is eliminated. And then I'm going to have minus 1,320. Oops. Minus 1,320 minus, which is plus 1,560. That gives me 240. Okay, so we can say K is equal to 240 over 5.685. So you have 240 divided by 5.685. And that gives us 42.216. So K equals 42.216. Now, in the end, we round to 3SF. So you end up with 42.2. There's K, and then we got to find what R is. Let's use this equation here. We can say R is equal to 520 minus 1.0364 times K. So that's 520 minus 1.0364 times 42.2 in its exact form. So I'll take this exact form and I will multiply it by minus 1.0364, and I'll add 520 to it, and that gives me 476.2469. Okay, 476.246 goes on. So we can see here that to 3SF, this is going to be 476. Okay, so that's K and that's R, rounded to 3SF in the end. Okay, and that's seems to be fine. And that's the answer to this question, question number 7, the last question from this paper. Other questions from this particular paper can be found in the playlist that will appear in this section of the video at the end of the lesson, or end of the video, sorry. And you'll find here a link to normal distribution questions from my playlist for that, from S1. And you can subscribe to the channel by clicking on this link. And the video that will be linked here tells you how to use my channel to find things that you're looking for efficiently. Thank you for watching and see you soon. Okay, one of the questions, by the way, that students were asking was about how to round the values. Now, in this case, when we are able to use the small table, we must use the small table. Don't go to the big table and have Z values which are not accurate. All right, which are less accurate. The Z values only will be in 2 decimal places there. So always use the big the small table at the top when you can. If you can't, then resort to the big table and you always, in your steps, give your accuracy as written in the table, but your final answer is rounded to 3SF. Okay, so I hope that's clear. Thank you for watching and see you soon.